So in this video we're going to show you how to factor by taking out GCF and then also factor by grouping, which is really just a glorified factoring by a GCF as well. So when you want to do factor out a GCF, you got something like 6x minus 12. And it's really the opposite of the distributive property. So you're looking for some number that comes out of both 6 and 12, which is 6, and you factor it out front. I'll put a parentheses here, and it leaves us with, if you take a 6 out of 6x, you're dividing it out front, you're left with 1x. Take a 6 out of 12, and you're left with a 2. Now you can always double check this by distributing. 6 times x is 6x, 6 times 2 is the 12. Always, whenever you're factoring, you can always check it by distributing it back. So let's try something a little bit more ambitious. Let's go with 12ab squared minus, let's go with 8a cubed b. Alright, so when we're looking at this, we're looking for a number that goes into both 12 and 8. We'll get to the a's and we'll get to the b's in a second. You really want to think of this as three problems: the numbers, the a's, and the b's. If there were c's, then there would be 4 problems. So deal with each one separately and you won't be overwhelmed. If you try to deal with the whole thing together, it looks kind of big. So I can't take an 8 out of both of these, and I definitely can't take a 12 out of 8. So I gotta look for the greatest common factor, which is 4. 4 goes into 12, 4 goes into 8. Now, we move on to the a's. Now, there's only one a here, a to the first power, and there's 3 a's here. I can't take 3 a's out of 1, but I can take a 1 out of 3. So I'm going to take a to the first power up front. Usually we don't show this 1 here because anything by itself is taken to be the first power. Okay, then we do the same trick with the b's. We've got 2 here and we've got 1 here, so we can only take out 1b. I think of this like a relay race. You're only as fast as your slowest player, so you can only take out the smaller number of the 2. Alright, we put a parentheses here, and we're left with, well, take a 4 out of 12, leaves us with 3. Taking the a out, you don't write any more a's left, there's nothing there. Taking 1b out of the 2 b's, leaves us with 1b. Take the 4 out of 8, leaves us with a 2. Take the 1 out of 3, leaves us with a squared. And take the b out, and you're good. You can always check it by distributing it back in. And you probably can do that in your head and make sure that you actually get what you started with. Alright, let's try another one here. Let's go with 2xy squared minus 10x cubed y to the 5th minus 6xy to the 4th. Okay, so when we look at this, we want to look at the numbers, we'll look at the x's, then we look at the y's. So what number can you take out? Well, everything's even. Always look at your smallest number. Does 2 go into everything? Well, it does. You can't go any bigger than 2 because you can't take more out of 2 than 2. Now we look at all the x's. Are there x's everywhere? There are. If one of these is missing an x, you couldn't take an x out of just these 2. You have to take it out of all of them. Alright, so we got at least 1 x in everything. There's no more x's than just 1 here. And we got 2 y's here, 5 y's here, and 4 y's here. Always the smallest y squared. I can't take any more than 2 out of 2. Alright, now this is kind of confusing right here. I'm taking the 2 out. Alright, it's gone. Taking the x out, it's gone. Taking the y out, it's gone. A lot of people don't want to write anything in this spot. We got 3 factors, 3 terms. Should be 3 terms here inside the parentheses. So 2 comes out of 2 once, not 0, but 1 time. Anytime you divide out, 2 divided by 2 is 1. It's not gone. So we have a 1 there. We didn't show a 1 here because you don't really put a 1 in front of x. It is 1x, but generally you just write x. Okay, so now we go into the next term. 2 goes into 10 5 times. 1 goes into 3 twice. You're subtracting them now. When you divide exponents, you subtract. Taking 2 out of the 5 y's, you're left with y to the 3rd minus 3y squared. I'm going to double check this, distribute it back. Think about this. If you don't have this 1 here, when you distribute, you're only going to get these other 2 terms. You will be missing this first term. So there's the 1. Alright, so the second thing we're going to talk about in this little thing is grouping. And in grouping, you're basically using the GCF twice. So let's say we got a 2x squared plus 8x minus 3x minus 12. Now, what the first thing that a lot of people want to do is they're going to want to combine these like terms in the middle. And you can do that, and then you can factor this by using something called guess and check. But grouping, I think, is a little bit easier. It's much more straightforward. So, and then actually when I show you the AC method in a different video, you will actually want it to be in 4 terms. So anytime you see 4 terms, I want to think grouping, as long as I'm factoring. At least want to try that. So the idea here is we're going to form 2 different groups. We're going to take the GCF out of each group. Now I said you have to have an X in everything. Well, that doesn't really apply here. I'm just looking at 2 at a time. So just looking at the left side here, I got a 2 and an 8, so I can take out a 2. The 2x's and 1x, so I can take out an x. Take the 2x out of 2x squared, leaves us an x. Take the 2x out of the 8x, leaves us with a plus 4. Signs are very important here. Alright, so there's that. Now in the second set, I can't take an x out of everything. I've got a 3 I can take out of both of these. Now one of the things that's a little bit tricky, and it's kind of rough to start with on the very first problem, is I really want the signs to mesh up. Anytime this first number is negative, right here, you're generally going to be taking out a negative number. So I'm not just going to take a 3, I'm going to take a negative 3 out. Alright, so what's that going to leave us with? Well, I'm taking the negative 3 out, so that's just a regular old x. I'm taking a negative 3 out of a negative 12, leaves me with a positive 4. If I want to double check that, I'm going to get a negative 3x and a minus 12. Works out. Okay, halfway there. The other half of this is now I'm looking at these big terms. Here, I got 2 terms now, not 4, but 2. Is there anything in common between these? Well, I'm hoping you're saying the x plus 4 in each of them. So I'm going to factor that out front, x plus 4. If I take the x plus 4 out of this first term, all that's leaving me with is the 2x. Remember, like when you do these parentheses, you take out your GCF out front, start a parentheses, and you put what's left over. In the second group, I take out the x plus 4, and it leaves me with a minus 3. And that's factored. Now, this is a little bit tricky. It doesn't quite look like what you're seeing. You can't really just see the beginning, so let's double check it. We'll FOIL this out. So you get a 2x squared minus 3x plus 8x and the minus 12. Now, the 3x and the 8x are in the wrong spots, but the 8x is positive and the 3x is negative, so it checks out. Now, one of the things that you're going to see, a lot of people will want to write this with the x plus 4 on the right and the kind of leftover stuff on the left. So let's see the 2x minus 3 out front. See, they see a 2x and they see a minus 3 out front. And they'll put this x plus 4 that's on the right side out to the right. Which one's right? Both are correct. I like the first version because it sticks with the whole taking the GCF out front. However, I swear more teachers and like math tutors and people you might see outside this video write it in this pattern. 2 things are both identical, so whichever one makes more sense to you, that's what you go with. They will both FOIL to be the exact same thing. Actually, if you go in this direction, you'll get the exact same thing you started up with, not the flip version. That's a kind of a weird thing that happens that way. Alright, let's try another one. Let's go with 28a squared plus 8a plus 21ab and plus 6b. Now, this one I can't really combine like terms. I don't have like terms here, so I just got to work with it the way I can. So if I can go with the first pair and the second pair I want to. So in the first group, I can take a 4, 8 out. Take a 4 out of 28, using a 7a, plus 2. And then the second group, one of the things you're going to realize, these have to be the same. So when I'm trying to figure out what I can take out of 21 and 6, it better leave me 7. So I'm going to go with 3. And there's b's in both of these, so 3b. Take the 3b out of here, leaves me with 7a plus 2. Now, 7a plus 2 and 7a plus 2, they have to be the same. If they're not the same, A is a typo, B it might be prime, or C, you just got to make sure that you actually factored it correctly. So what do we have? We have the 7a plus 2, we're pulling out front, and then the leftovers, the 4a and the plus 3b, or the switch of these two. Doesn't matter too much. You can always FOIL it to double check. Alright, let's try one more version of this. And let's go with 9mz minus 4nc plus 3mc minus 12nz. Alright, so we got 4 terms, so we're going to try grouping. Now, if I look at my first pair, 9 and 4, that doesn't seem to do anything. I don't have m's in both of them. I know it's n sometimes looks like an m. ZC don't work. Over here I can take a 3 out. You see that, but it doesn't really work for me. Alright, so if the grouping doesn't work, try a different grouping. Okay, so I can either go with the first and third, or I can go with the first and fourth, and the second and third. Whichever grouping you see, that becomes the right grouping. There's a couple things you got to be a little bit careful about here. If I go with this group, we got a couple positives, a couple negatives, so we got some sign issues here. The other thing you want to be careful about, so if I go with 9mz plus 3mc, and I would suggest rewriting it. Notice I've got the large number up front and the small number up second. So when I write these other two, I'm going to preserve that. If you don't, you'll end up getting two factors that are the same but don't look the same, and it could be a little confusing for you. Alright, now that we've rearranged it, we do the same thing. Take a 3m out, leaves us with 3z plus c, like it. And then the second pair, it's a 4, but remember when I said that this number out front's negative? We're going to take a negative 4, and then out. Then we get the 3z plus c. And now everybody's happy. 3z plus c is my one factor, and the 3m minus 4n is my other. Always flat out to check them if you'd like to, but that's the main thing. Now, one thing that we didn't really have in any of these is sometimes you will look at the problem and it'll have a GCF right in the beginning. Or you'll end up with a factor in the end that's something like this, 2x plus 4 and a 3x minus 5. This might look good. This is not done. There's a GCF in there. If you look at this 2x plus 4, if I looked at that from the very beginning, the very first thing that we had, take out a 2, leave us with x plus 2, and 3x minus 5. A lot of times when people do grouping, they don't look at the original problem and say, is there a GCF? Always check for GCF first. Always check for GCF first. Now in the very end, look at your answer. I don't have a GCF here. I don't have a GCF here, so it's good. But if you do, you still have to take it out. If you forget in the beginning, double check your answer at the end. You can check it there.